So first things first, Pete, let's talk about where copper comes from.
Okay.
Yeah?
So, out of the ground.
Yes, so here we have an example of what copper, this one's been acid dipped so you can see the different colours, but in essence, copper is a natural product.
So that's just buried in the ground somewhere in the world,
Yep,
in rock,
yep.
and that's mined.
So yeah, they reckon there's over 200 years worth of copper sitting in the ground.
Yeah.
And it's mined at various depths, and it'll obviously have rock in it. And you've got the copper that you're going to be using to turn into this product. There's nothing to be added. It's just you've got to separate the copper ore, if you like, from the rock, and then you can make it into copper because the tube itself is 100% what comes out the ground.
So as far as I understand it, you'll melt that down and there's a process to remove the copper from the rock.
Yep.
And it comes out after that process in like these big sheets of pure copper.
Yes, so you're extracting the copper and then you'll turn it into cathode. Copper cathode is literally just pure sheets of copper that have been separated away from all the other bits and bobs that you get out of the ground, and you're left with just a sheet of copper. You then take that sheet of copper out, you then melt it into what's called a billet, so it looks a little bit like this fitting, but just imagine it's solid, not hollow, and that's
So
called a
something
copper
like
billet.
that, but completely solid.
Yeah, and it weighs about quarter of a ton, something like that, half a ton. And then you're superheating it, and you get this billet. And while the billet's still really hot, you're just going to force through what they call an extrusion press. You're going to force a harder metal, like steel, into that billet of copper, and out comes at the other end, in very simplistic terms, a piece of copper pipe.
So basically, a solid piece of copper like that as a billet.
Yep.
Smash a harder metal through it,
Yep.
and that creates
While it's still hot.
still a really thick, really big, but rather than solid, it's then a tube.
Yes, and that's then called what's called a mother tube. So
Yeah.
that thicker tube is then going to be drawn and drawn and drawn until you get to the finished size.
And when you say drawn, I normally describe it as being stretched. So you have that really thick, what did you call it?
Yeah, so here, for example, at Lawton tubes, we can go as thick as about 8 millimetres thick.
So you have your mother tube, which
You have
is
your mother tube.
8 millimeters thick.
Yeah,
You then draw it or stretch it.
yeah, in a draw bench.
And as you do that, it gets thinner.
Thinner and longer. You can't go shorter and fatter, you can always go thinner and longer.
And there is a rule, isn't there? You can't go, so if we've got a mother tube this size, you can't go all the way down to say 8 mil. You've
Not
got to
in
do it
one fell swoop.
stages.
No, because that wouldn't be efficient. So you'd start off with your mother shell as close as possible to the finished product. In some instances, you can actually come out as a finished product, but more often than not, you'll start with a closer wall thickness to the desired finish. So if you take 15 mil, for example, it's 0.7 mil thick as a finished product. You'll try and draw that down as less times as possible, least times as possible. Yeah, because it drives efficiency.
But the process of making it, it's not just we draw it, stretch it, and it's done.
No,
It's
you've
just
got
the first
cutting,
stage.
you've got, yeah, so there's quite a few processes. And at Lawton tubes, we take the mother shell, we draw it down to the size we want, whether it's shaped, whether it's round, and then we'll cut it to length. We'll put it back into the furnace because you work hardening every time you draw a tube, you'll make it naturally harder. And of course, obviously 15 mil plumbing tube is going to be half hard because you want to bend it with a pipe bender. And we can talk about that in another series. If you have microbore, you're going to want it soft. So depending on what the application, what you want to do with it, you'll put it back into the furnace for X amount of time. And that will give it back to a half hard. You then also, on plumbing tube, part of the standard is you've got to mark it. And we do two things at Lawton tubes. We'll do an inkjet marking, which is a lot easier to read, but it'll rub off. What you have to do, part of the standard, is engrave it. So we have engraving machines as well. So you'll put our name on it, when it was made, what the standard is, all that sort of information that you'll get. You then put it into a degreaser, we call it, which basically takes away any grease, because on manufacturing a copper tube, it's really just brute force. So when you've done your extruding, like we just mentioned, when you get to your finished size, you're literally putting it through what they call a die and a plug. So a die goes on the outside of the tube, and a plug goes inside the tube, and the combination of the two creates the wall thickness. Yeah, so it creates the OD and the wall thickness, and you're using grease and a bit of brute force, so you need to get that off and out, because obviously the cleanliness needs to be really clean, and there are different standards depending on the application. But on plumbing tube, you need to have it relatively clean. So you put it into the degreaser, clean it all off, and that pretty much, and then you've got a little bit of packaging, and a Bob's your uncle, you've got yourself some plumbing tube.
And that what you just described is to make, say, a standard length of 15mm tube, which is what I would use at work.
15 all the way up to 219 would be pretty much the same process. Yeah.
But the process in the factory, you can do pretty much anything. If your customer rang you up, so this is a 15mm outside diameter, 0.7mm wall thickness.
Yes.
But if someone rang you up and said, I wanted a 17mm outside diameter and I want it 1mm thick,
yeah,
you can do that. You just have to change the
plugs and dies, and the starting tube.
And that also applies to if someone wants a rectangle.
Yeah, so that actually, believe it or not, will come from a round tube to start with.
Yeah.
And you're just using a different shape die, as they call it. And that would be a rectangle on this particular one. And there's different sizes. You can do different types of shapes, rectangles and stuff like that. But for plumbing tube, it's always going to be round. And then what we also do in the factory, here's an example of some plastic coated pipe, right? So Pete, you probably know this like anybody. What would you use plastic coated tube for?
So I know if you're fitting this in certain countries, they put it on the outside of the building, and it's to protect it against the weather.
Yes, that's one reason. So there'd be some UV protection in there as well as.
If you were going to bury it in the ground. Maybe.
Yeah. So if you've got contaminated ground, and you again want to protect the copper, you'd have a plastic coated. But it's also there, isn't it, to identify what is actually inside the pipe.
So if that was yellow, I would automatically say that was a gas pipe.
Yeah, so you lift up the floorboards, oh bang, there's some yellow pipe. You would think that was for commercial gas, or getting gas from the mains to, let's say, your gas hob or your combi boiler. You would use yellow plastic. Blue would probably be for water. In this instance, white, in Scotland in particular, but other rural areas, there's a lot of oil that goes into heating your house. So that would be using white, and that would be an 8 and 10mm, for example, rather than this size. And then also what you have in different coatings is chrome.
And that's chrome plated.
This is chrome plated. So again,
tube.
it's that, yes. And it's chrome plated because it's decorative, is what we call it, really. So it's got a little bit of nickel on the diff between here and the chrome. The reason why it's nickel plated is because the chrome won't naturally go straight onto copper. So the nickel is like a bonding agent, if you like, if I suppose is a better word. So there's a little bit of nickel underneath there, and then it goes and gets chrome plated. And you'd use that in what, your bathroom?
Yeah. So question, because obviously you've got a copper tube, and then you're nickel plating it to allow it to take the chrome.
Yep.
Is that purely decorative? Was there any other reason why we needed to have a chrome?
Chrome is because people wanted to have in their bathrooms, they wanted to have a decorative product. So there are some products out there that could clip onto the tube, but if you wanted to use it, and of course you can get chrome plated fittings.
Does it offer any extra protection?
No, it's purely decorative.
Okay.
Because don't forget, it's what's inside the tube that counts. So you've still got copper touching water.
Here's a question. You might not know the answer to this, but does the OD, the outside diameter, change?
Oh, it's microns thick.
So
microns. It won't make any difference. So you could still use normal fittings and all the rest of it.
Okay.
You're meant to strip off the chrome, right? So you'll have a tool that you, same with say if you've got painted tube, and we can show that in another video when we actually get into the how-to videos, but you'll try and remove the chrome.
Yeah, obviously
coating.
if I was going to solder on that, I would need to remove the
Yes.
chrome so I can solder it. But what about going into compression fitting with a nut and olive?
No, that's fine, because it's a mechanical joint rather than using solder.
So another question I wanted to ask. Obviously this is a half hard.
Yes.
Which means we can bend it. So if it was fully hard and I put it in a bender, it would just snap.
Yes.
Correct.
Remembering that copper melts at just over 1,000 degrees, and you're just using your furnace, if you like, because as you produce a tube, as you extrude the tube, and every time you draw a tube, you're naturally work hardening. So if you keep bending that microbore backwards and forwards, it's going to snap because you're work hardening the metal. And that's what the difference is. So this would be what they call R250, that would be R220. This is half hard, that's soft. Now the difference is you can get this as 15mm and 22mm in the coil, but because of the temper and the fact that's softer, you have to increase the wall thickness in order to get the same working pressure. So this would be working pressure about 55 bar as a half hard tube.
Yeah.
If it was in the coil, you have to make, so this is 0.7 mil thick. To have the same working pressure, you're going to have to make it 1 mil thick because it's softer.
Yeah.
So the softer the material, the thicker you have to go to get the same working pressure.
Okay, and this is...
And vice versa, the harder you go, the thinner you could go.
And then we've obviously got that giant, that's the biggest fitting you do here, isn't it?
Yes, so in plumbing we do from 6 mil, which is not so common these days, all the way up to 290 mil. And that is the largest fitting that we do in a seamless... So
do you do 290 mil tube?
If you can imagine, there's going to be some big pipe in
what
there.
What length would
6 metre.
That's the longest you can do?
219 mil, but by far the biggest volume. So by far the biggest volume is 15, 22 and 28, which is what we call domestic pipe, right?
Yeah.
And all of the different products, so the fittings come to a standard of EN 1254. All the tube, whether it's plastic coated or chrome plated, the tube underneath will be to EN 1057. So Lawton Tubes is predominantly always been about copper pipe, right? Okay, and that's now made to EN 1057.
And that's the British standard.
That's the British standard.
That says when it leaves the factory,
Europe.
it's got to be this table. So that's the wall thickness.
Yeah.
The cleanliness, everything to do with that pipe has got to meet the British standard before it leaves the factory.
So a little bit of a history lesson for those that are interested. Go back to 1976. I think that's probably as far as we want to go. In the 60s, it used to be lead pipe, and they realised lead's poisonous, so they decided to defunct lead, and that was around since the 16th century, right? So in 76, they decided to come up with a proper standard for copper pipe, all right, called 2871. That was when it really came into its own. And then that had tables in it, and some plumbers and gas engineers still relate to table X and table Y, and even table Z. And those three tables basically are the tube that we know today, but with different wall thicknesses. All that's done is really where they've combined the 2871 and the tables into another standard called EN 1057, which we all know today, that happened in 1996, and they amalgamated all the tables into one. So everything's made to EN 1057 when you come to copper pipe, whether it's plastic coated or chrome. There are different standards for the chrome plating and the plastic coating, but in the tube itself, it's all into EN 1057. Okay, so we sort of covered the standard on copper pipe. On fittings, so we've got a small selection of fittings that we offer at Lawton Tube. We've got some end feed, some soldering, some compression, and our more later offering, which is the press. That's all made to EN 1254, and they're all in different parts based on that standard. But in essence, they're all doing the same thing. They're creating a joint. I know when we talk about traditional plumbing, and I know you're a big advocate of traditional plumbing, you want to do as least number of fittings on the job because flow rate and stuff like that.
Flow rate, it obviously changes the way the water's moving through the pipe. There's more chance of it leaking. If you can get away with pulling a bend rather than having a fit in, then there's less points for it to leak. And it's, in my opinion, it's one of the skills of being a plumber.
Okay.
Bending copper tube.
Yep.
So it's quite important.
So on another one of these episodes that we're going to be doing, we're going to be talking through about how you press, how you solder, compression, and there's pluses and minuses for each one, right?
Yeah.
It's down to personal preference.
Yeah, because I've done my whole career now. I've been a plumber since I was 17, so 25 years, and I've never really used a ring fitting.
Soldering.
Because when I started, my dad wasn't using them, so then I wasn't using them.
No.
But a lot of people will.
Yeah, and depending on which part of the country you're in. So if you go right up north into Scotland, they seem to be using more soldering than any other part of the country. End feed is everywhere. Press, that's becoming very popular. It's almost 50-50 between end feed and press these days, which is a more modern way, and we'll do a talk and conversation about it.
So obviously we've covered where copper comes from out of the ground, but I know when I rip out a job, for say put a new central heating system in, I then take that copper to the scrap man, and I know that then is recycled and basically made back into copper tube, and that's something that you're big on at Lawton Tubes.
Well, sustainability is a big thing, and obviously it's a natural product. And our domestic tube 15, 22 and 28, which is by far the bulk of what we sell, is 100% recyclable. And it comes from a recycled source. So on the 15, 22 and 28, it's what we call mass recycled. So there is a proportion of recycled product, and it's becoming more and more, because the more and more you install and the more and more you rip out, the more and more there's product available to be recycled. And that's the beauty about copper. There's no loss of quality when you recycle, and you can keep recycling it forever.
Because you could have two lengths on the table here. You could have a length of 15 and another length of 15. One of them could be brand new from the ground, and one could be 100% recycled. So all of it is from recycled material, but they'll both leave this factory under the same British standards. So they'll be the same quality, same wall thickness.
Yep, same composition.
Identical.
Yep.
Apart from one of us.
99.9% pure copper is what the standard says. So a little bit of trace of tin and a little bit of trace of silver. You're not going to get 100% pure, but it's 99.9, so it's pretty much there. And it doesn't matter whether it comes from a recycled source or whether it comes out the ground. The finished product is the same. Same guarantees, same standard. It does the same job. So you're not going to be able to tell the difference.
So that's everything copper related covered.
Yeah, pretty much. We talked about the product, we talked about where it comes from, recyclability.
If you've got any questions about anything we've just talked about, he's the man to ask, he's the copper man. So leave us a question in the comments and we'll try and answer them for you.
Yeah, and I hope you enjoyed the first episode.
High five.